Alright, so problem 29 is about Superman getting shot with a bunch of bullets, and what is the average force on his chest from all those bullets. Surprisingly, it's not a lot. Bullets are tiny, but it's okay. Superman can handle it. So the mass of each bullet, oops, hi, the mass of each bullet is 3 grams, which turns out to be 0.003 kilograms. And the speed of these bullets, pretty speedy 500 meters every second. So what's the, first off, we're going to need and it says they bounce back at the same speed. So that bouncing back should clue you in to main concept 1, impulse. An impulse is when your momentum changes, which means either your mass changes, which usually isn't the case, or your velocity changes, or both, which is probably more often the case than just the mass changing. And not only that, but it requires a force to change something's velocity, to accelerate something, so force over a time duration will give you your impulse as well. So let's do that. J equals Ft. J also equals delta P, which is m V final minus V initial. So the mass, we'll do this first, 0.003 times, let's define a direction real quick. Like, let's say that Superman is standing here, and bullets coming in this way, hits Superman, bounces back that way. So let's say that this way is positive and this way is negative. Alright, so that means the final velocity bouncing back this way is positive 500 minus initial velocity is that way to the left, negative 500. That trips a lot of people up. There's a homework problem where in the WebAssign where something bounces or ricochets or whatever. Don't forget that it's velocity, not speed, so one of them has to be negative, the other has to be positive. This turns into 3 kilograms meters per second as the impulse. That's cool. That's per bullet, by the way. So we got this guy right here. Force is impulse over time, which equals 3 kilogram meter per second divided by time, which, so let's do the rate. We can do a rate here, which is really interesting. So we know that there's 100 of these impulses. Each bullet imparts 3 kilogram meter per second of impulse. So if there's 100 of them, we get 100 of those. Plus we know that 100 bullets hit him in 60 seconds. Now since we're doing an average, we can do this. Otherwise, it probably doesn't make sense to you. Like, wait, 60 seconds? Each bullet only touches him for maybe like a tiny fraction of a second. Graphically, what I'm talking about is the real force graph might look something like this. As each bullet hits, the force goes up and down real quick, right? And that happens 100 times in 60 seconds. But the average force, which is the average of all of these over 60 seconds, might be something like this, where the area under here is the same as the area under all these little spikes. So we can do this legitimately, and we'll do it. So that's 300 over 60, which is 5 newtons of force on average for all of them. Pretty cool. So the thing to take away from this is the fact that momentum is a change in velocity. Sorry, impulse is a change in momentum, And also the average force is impulse divided by time. Alright, next problem.